Okay, in this clip we're going to look at elasticity. Again, a subject that often trips up aspiring young economists, initially anyway. But it's a vitally important part of the study of the subject, so you got to make sure you nail this one. Elasticity answers this key question that we've been looking at so far. We know that if we raise the price of a good, demand will fall, or if we raise the price of a good, supply will increase. What elasticity seeks to solve is how much does demand change given a change in price. And what we find out is that all sorts of products have different responses. It depends a great deal on the product, on how much it's needed or required, above all else, how substitutable it is, the time period, long-term, short-term. All sorts of factors conspire to determining the response of a demand for a product given change in price. This is the price elasticity of demand. We see price elasticity of supply, we have income elasticity of demand, and we have cross elasticity, which we'll look at in other clips. But I wanted to start with the price elasticity of demand, PED, initially. Really, the most important thing to really nail this is to, first of all, recognize what is elasticity. It is responsiveness. It is how much does demand respond to a change in price. You might want to just look at something like this. This is a rubber band, otherwise known as an elastic band. Elasticity, it responds. If you pull it, it will respond. Oh, that is an elastic response. On the other hand, this is inelastic. I pull it, it does not respond. Okay, so this is where the term comes from in any event. Responsiveness is measured in percent terms. I think the best thing to do is start off with the formula. Price elasticity of demand equals the percent change in quantity demanded divided by the percent change in price. Delta meaning referring to change in math or in economics in this case. The percent change in quantity demanded divided by the percent change in price. I think if any student memorizes that, they'll find the whole process of calculating elasticity easy. If they don't, it becomes difficult. Another calculation for PED, basically the same thing, is price divided by quantity, the original price divided by the original quantity, multiplied by the change in quantity divided by the change in price. Either of those two methods will provide you with the calculation you're looking for. So, percent change in quantity demanded divided by percent change in price. What this effectively means from a diagram point of view, here we have our quantity here and our price as usual. We'll see that here is a demand curve, a normal demand curve. And at this price, we have Q1 and P1. And what we want to see is if this price was to rise here, how much does demand decrease with that price rise? This would appear to be, in many respects, it might appear unitary. A 1 unit increase led to a 1 unit decrease in quantity. That's not always the case. If we have a very inelastic demand curve, that would be a very, very steep demand curve. And it would look something like this. And you can see here, at this given price, P1, we have a Q1 is demanded. Let's put price up a lot, from here up to here, to P2, and look. There's only a tiny little change in quantity demanded. That is a very inelastic demand curve. Likewise, if we had a very elastic response, that would be the opposite. The demand curve would be far more horizontal like this, and what you can see here is that our original price, our original quantity, if we put price up just a snick to P2, we see a much more disproportionate drop in the quantity demanded from that. So the slope of the demand curve will determine what the will be a visual idea of how elastic the response is. So let's take a look at a working example. Let's say we have price and quantity here, and we start off with a price of 20 pounds. The company is able to produce is able to sell 1,000 units per day. And this company obviously wants to maximize revenue, so it's considering, it goes, what should I do? How about if we increase price to 25 pounds for this good? What will happen? And they go out, we test the data, and they say, yes, we increase the price, and demand certainly dropped, as it does. A lot of demand will say demand will go down, but demand only fell to 900. So they think, okay, well, what does this tell us about the product? Well, we do the percent change in quantity demanded divided by the percent change in price. And what is the percent change in price that's taken place? Well, first of all, it's essential to realize you always start with a starting price. From 20 up to 25, the change in price has been 5. 5 goes into 24 times, so it's a quarter, or 25%. There's been a 25% change in price. Note, you never start with the final price, because the change in price going from 20 to 5 is 5. That's only a fifth. But you always start from the starting price, so it's a quarter. 25% change in price, percent change in price is 25%, as we've seen. What's been the change in demand that's occurred? We've gone from 1,000 down to 900. That's been a percent change in quantity demanded is 10%. So what is the elasticity? 10 over 25 is equal to 0.4. 0.4. That's less than 1, it's less than unitary, so that's an inelastic product. This is something that the company would be very happy to have. They put the price up, the percent change in price is greater than the drop in demand, hence, happy days for the company, they're able to make more money. If, on the other hand, we saw something where demand, in this case, fell to 500, we would see a 25% increase in price led to a 50% decline in sales, and that of course would be an elasticity of 2, which is greater than 1, 1 being unitary, 1 being, if it's unitary, a 1% change in the price would lead to a 1% change in demand. This, however, shows an elastic response. It's more responsive. You've increased price, and demand has dropped far greater, so the amount sold is far greater than the extra revenue earned, and that would necessarily be a bad thing. Companies tend to prefer to have an inelastic product if they're raising prices, and they want to have an elastic product if they're cutting prices because they want the response to be even greater. One last thing to mention is that PED is always negative. Because a rise in price leads to a cut in demand, or a fall in price, decline in price leads to a rise in demand. The numerator or the denominator is always negative, one of them two, therefore the outcome is always negative. Because PED is always negative, we say we don't need to be able to put the negative or positive sign in front of it. It's always just a unit of the number is just 2 or 1 or 0.5 or whatever. Hope that's good enough for you.